record it, and we can start sharing screen. So first, I will do a quick review about Huffman tree. Okay, so yesterday we already started to discuss the Huffman tree. Why it won't work? The draw already started. My pen doesn't work. Hold on, okay. Let me try. Oh, okay. Looks like I needed to press hard. So yesterday we discussed the Huffman tree. Okay, and we know for the Huffman tree, it's a variable length of coding. Not like ASCII or Unicode, is that it's the same length. Okay, ASCII code is 8 bits, and Unicode is 16 bits. And for Huffman tree, Huffman coding, it's variable length coding, so it can be used for compression. Okay, and the second feature for it is it must be immediately decodable. Immediately decodable. And what that means is one letter's code shouldn't be prefix of another letter's code. So that's the major feature, okay, for Huffman code. And we also discuss how to build a Huffman tree, is it? And we call it a double tree. So it's bottom up, is it? We build it. And we also, so if you have the letter and the code, is it? So once you have the character and the code, is it? Then we can use, so generally speaking, we call this a code file, is it? Okay, and then you can use it to build the Huffman tree. Okay, and for Huffman tree, it's when we build it's top bottom. Bottom way to build the tree. So you you read through the code. That we read through the code and until the end of the code, and then you add the corresponding letter as a leaf node. Okay, and generally speaking, we don't call this binary tree, we call it a double tree. Okay, and let's take a look and get a quick review of how this works. So you suppose we have that char and code, is it? Suppose we have B and then the code is 0, 0, 0, 0, is it? Then we have C 0, 0, 0, 1, and we have D, it's 0, 0, 1, and we have A, it's 0, 1. And the E is 1, is it like this? And if we build the Huffman tree, the way to do it, to build it, you start like from the first code, is it? And it's 0, so it's go to left. And then you add a star. And you move next, it's 0. So we go to left and we add a star and they keep doing like this. And keep doing like this, is it? And you reach the end, we have 4, 0, is it? You reach the end, and then it's you add the leaf node, so of a letter B, is it? So same thing for C, it's 0, 0, 0, and over here it's 1, so go to right, then you add C, is it? And for D, it's 0, 0, 1, so 0, 0, 1. So this is our D, is it? And for A, it's 0, 1. So this is A, is it? And E is 1, so it's go to the right. So it's based on your code. Is it you go to left or go to the right? So that's how we construct the Huffman tree. Construct a Huffman tree. Okay, so that's the algorithm. So just a quick review of the algorithm. And oh, I shouldn't erase that. Okay, and let me just get at least part of it back to explain. And then 0, 0, 0, 1, 2, 3, 4, 0, and we have B, is it? And then we have C here, it's 1. And we have D here, it's 1. And we have A here as 1. And then we have E here as 1, is it? So this is our Huffman tree we already built. And the usage is after you have this, sometimes you got the message, is it? We call it a message file. Okay, what is the message file? It's just a code, is it? It's 1, suppose, and then 0, 1, and then 0, 0, 0, 0. This is suppose the example 0, 0, 0, 1. And this is the end of the file. Okay, so this indicates end of this file. Okay, all of this, we call it the code file, is it? And so you receive some just 0, 1s, is it? How do we decode it? Is it? So the way to do it, you get you do 1 by 1 reading, is it? In this case, it's number, is it? And okay, you read 1, okay, go to right, and you reach the leaf node. So you know, okay, it's going to be decoded as E, is it? And then you have 0, you go to left. It's not leaf node, so you keep going. As it's 1, okay, so you reach, so you know, okay, this is A, is it? And the same thing for the next, it goes 0, 0, 0, 0. You know, you go to 4, 0, then you will reach B, is it? So then this part, you decode it to B. And the same thing for the last, is it? 0, 0, 0, 1. Then you find it's a C, is it? It's a C, is it? So we can use a message and then decode it, is it? So that's the general idea about how the Huffman algorithm works. So let's go back to the coding part to see how do we do all of this, okay? So first, let's take a look at the Huffman. Okay, so over here, we define a class. We call it a Huffman. And we still need a bin node, okay, because we have left branch and right branch, is it? And in this case, the data part is a character, okay? And you have the left and you have the right, okay? Both are the type of that bin node. Okay, so nothing new here. Compare with binary search tree, okay? And for this Huffman tree, is it? And we just need this single node, the root node. So once we know the root node, we can get everything, okay? And the constructor, the start, the root, and you remember A, B, C, D is always, so those letters are always at the leaf node level, the lowest level. So the root, generally speaking, is just whatever letter you want to assign for not part of the coding. So in this case, we use asterisk to represent. So for the constructor, you just let the root node has that asterisk. And then next, let's see. So the first part is we are going to build. So the first part, you need to build that tree, is it? So we call it a decoding tree, okay? The Huffman decoding tree. So that's the first part. So the first part is you have the, we have those like B and 0, 0, 0, 0, something, is it? And C 0, 0, 0, 1. So this is from the a file. We call it a code file. And based on this, you're going to build the tree. That you're going to build the tree. Is it? And oh, okay, over here CS1. Is it? So based on this, you're going to build the tree. So how do we do this? Okay. So over here, we use the scanner and we open the file. Is it? So this is from the file processing part we already know. And then we just get next. Is it? Has next and get next. So first in our file, it's formatting like this. Is it? So you get to the letter. Is it? Get to the letter. Okay. And if it is the asterisk, that means the end of the file. So we are going to stop. Otherwise, you need to get to the code part. So the scan that next will get to the code part. This gets the first letter. Is it? After this, then you're going to start to build the Huffman decoding tree. So we call that insert. So the insert is regarding the tree part. And this part is just get to the file input, okay? And then let's see the insert part, how it works. So for our insert part, you remember we have the letter is this, so this corresponding to like the B part and the code corresponding to this part. Is it the 0 and 1s? Then you're going to, so we already have the root node, is it, for our Huffman decoding tree. And then you're going to loop through this code part. Is it? Loop through this code part and one by one. Is it? So if it is left, if it is 0, is it? And then we know that it needs to go to the left, is it? And here you also need to know, okay, if the left part doesn't have anything, is it? Then you need to start to build that. Remember, that's how we did that, is it? So 0, and then you need to create this bin node, is it? Create this bin node, and it is the left, is it? You assign it, you at simultaneously you also move, is it? So this P also serves as our cursor, is it? And then you advance it to the left, is it? Or if it is 1, then you go to right, is it? You go to right, is it? And you set it as the star, is it? And then you keep going, is it? So that's how you do this. And otherwise, if it's not 0 and 1, is it? If it's not 0 and 1, then that means your file is not correct, is it? So over here, we can throw an exception, okay? Because this method, we deal with some illegal information from the file, is it? But be careful at the very last, is it? You need to update the leaf nodes information with the corresponding letter, okay? So this part, compare, if you take a look, compare with our binary search tree part, it's simpler, okay, not that complicated. So just based on 0 and 1, you go to left or go to right, is it? Okay, so that part you build the tree, they build the Huffman tree. And after you build the Huffman tree, then the next part you can use it to do the decoding, is it? So this part, what this part does is, this code file, that's our message. Is it message? It's like, okay, you have E, is it? And 0, 1, and then 0, 0, 0. Is it our example? Is it you have that? So it's all contains all of those digits, is it 0 and 1s. And then this method is supposed to give you the output of that E, A, B, C something, is it? Okay, so how do we do that? Is it? So you have the file, is it? And over here, we open it and line it, associate with a file reader, okay? And after that, we also, and this time you always, because your tree is already here. is it your tree is already here? Okay, 0, 0, 0, is it? And 0. Oh, and here is that B, is it? Here's B, and here is 1, and here is C. Is there something like this? That's our tree. So the tree is already here, is it? The tree is already here, and then you start at the root node, is it? Start at the root node. And you check if left and right, if it's it's not null, is it? Because if it's leaf node, you're supposed to stop, is it? And then you can try to read this single digit, is it? So the file reader, for file reader, and if you call the dot read, it will return a single character. Okay, it's because here we need to do letter by letter reading, is it? But what is the return is a integer, so we need to cast it. Okay, so you cast it to back to a character, is it? Because we need to compare if it is 1 or 0, is it? Okay, you said, okay, if it's 0, then you need to go to left, is it? You advance your cursor to left. If it is 1, then you advance your cursor to right, is it? And if it is a star case, then you're going to stop this decoding. That's the end of your message, is it? And then in this loop, is it? Then you can just go ahead. When you reach the leaf node, is it? You will get what the letter is. So I can output the letter. Okay. So this is the decoding part. Okay, decoding part. And then next, let's see. Over here, how do we print out? How do you print out the tree? Okay, how do you print out the tree? The tree that we that the Huffman decoding tree, is it? So over here it shows how to do the printout. So you can specify the so this is the bin node, is it? We always start from the root node, okay? And over here, we will have the indentation. So probably first let me run this, okay? So that you will have an idea what the output looks like. So that's what the Huffman tree looks like. And it's horizontal, okay? So in this case, here is the root. Here is a root, okay? And basically it's something like this. Is it something like this? And over here it's this, and over here it's this, okay? And over here it's this, and it's oh no, it's this one. Is it? So it's that's the what the tree look like. Okay, it's a horizontal. Okay, and then basically it's over here. And if we want to have some output like this, that's kind of complicated. Okay, but if you're interested, there is a way you can also output some dashed line. Okay. And there are some available solutions for that. So in summary, if you're interested, you can go ahead. So we have a simple version, okay, the easy version to understand looks like this. So that's what the output looks like. How do I stop this? Oh, how do I stop this? Hold on, let me, I want to get back to a file. Oh, not this one. Oh, over here, the print tree, okay, method. So the print tree method, what it does is it will start at the root node, is it? So it first do print the print write, basically. You plug in, you're going to plug in with the right branch, is it? And here you're also going to increase the indentation. That's what you just saw, is it? You just saw. So this is the indentation. Okay, indentation. Okay, so it's going to, because this is recursive, is it? You call the print tree. So within the method, you call it self, is it? And you call it self, and so this +8 will keep accumulate. Is it so? So each further branch, is it will keep adding the indent. Is it okay? And then for this part, so what it's going to do is just do the print. Okay, print the corresponding data. Okay, it's either the star, or if it's the leaf node, is it? It's going to be the B or C something, is it? So that's what this part going to do. Okay, print. And all of the space, is it? It's based on how further away the indentation is going to be, is it? So we are going to do, because it's whenever it prints, it's always start at the very left, is it? So it's going to based on the accumulation of how many indents it is it? And then you're also going to print the left, is it? So that's how you get the train print out. And so that's the recursive function itself. This is just kind of like our binary search tree. We have that in order or pre-order or post-order traversal, is it? So that's the recursive part itself. And then you need to have another method, is it? Within the method, you need to call it, is it? Call the recursive function and plug in with the root node, okay? And specify the indent. We start at 0, is it? And it will keep accumulate, okay? So that's the idea about this Huffman coding, Huffman coding starting from the tree, is it? And we build the tree, and then we can also do the decoding. So that's the major thing. And then we over here we show the application part, okay, with the file. So we have a code file, okay. The code file is by line. Each line you have the letter, and then you have the corresponding code. Is it something like this? And the D001 probably. Is it something like this? And 1. So this is a code file. With this code file and the Huffman tree, so over here we needed to have that instance, okay, instance, and then you can call the building the Huffman tree, is it? And plug in over here in this case is our code file, okay. So that's regarding this part, and then we can display our decoding tree, is it? The display part is what we just show, is it? Just show, and then maybe over here it's B, etc., and maybe over here then it's C, etc. So that's the display, the decoding part, okay. And what the next part to show is over here. We have another file, is it? And this file is a message file. So this message file is what you have, is it? So you have some secret code, is it? And then you can decode it, is it? Like this is E something, is it? And then in this case, we initiate with a file reader, is it? Then we just call the decode method, is it? So you do need that Huffman tree be built first, okay? And then you can decode it, okay? So this is the general idea about Huffman tree and its application. And here, be careful, okay, for Huffman tree, you can see, for each file, is it, if the file is different, then your Huffman tree is also different, okay? So you need, when you do the decode, you need to use the corresponding Huffman tree to do the decoding, so that you can get the correct letters that match whatever from your file. Okay, so basically that's the general information about Huffman coding. And so we are done with all of the information. And